Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve past paper from EJU Mathematics 2018, first section, course 1, question from section 3. Basically, this is the fifth question from this past paper. If you want to watch the solution for the other number from this paper, you can check link on the description box below. And you can also check my EJU playlist if you want to watch the solution from the other past paper. Okay, before I start, if you like this video, don't forget to give your likes and share and subscribe my YouTube channel. Okay, on this question, we have n, which is two-digit natural number, such that the remainder of n cubed divided by 66 is equals to n. We are to find the numbers of such n's and to find prime numbers among them. From the condition, we have blah blah blah. Conditions here mean the condition that this question already introduced to us, which is from the first sentence here. If you can see here, n, when it is divided by 66, n cube, yeah, when n cube divided by 66, the remainder is equals to n. If I have a number, for example, I have a random number, for example, let's say 18, and then I divide it by 5, then the answer is 18 divided by 5 equals to 3. The remainder is 3. So I can write down as 3 over 5. This is the remainder, and then this is the divisor here, yeah. 3 over 5 we can write down as 3 plus 3 over 5. By using the same concept, when I have n cubed and then I divide it by 66, n cubed divided by 66, it is equals to the quotient. We do not know the quotient here, so I can assume the quotient here as p plus the remainder is n over the divisor is 66. If I multiplied all the terms by 66, then I will get n cubed equals to 66p plus n. I think this is my first answer. N cubed is equals to AB, so AB here is 66p plus n. I will erase this. My answer for AB is 66. And then this equation or this expression only follow n between 0 less than or equals to CD. As you can see here, n is the remainder. That means n must be greater than 0 but less than or equals to 65. Because if n, let's say 66, we do not have any remainder, because 66 over 66 is equals to 1. So CD here is 65. 0 less than n less than or equals to 65. This is my answer for CD. And then, where p is the integer quotient of n cubed divided by 66, yeah. As I mentioned earlier, p is the quotient when we divide n cubed by 66. This can be transformed into blah blah blah. So now I need to transform my equation. If you see from my equation, I can move n to the other side, then I will obtain n cubed minus n equals to 66p, and of course I can factorize n cubed minus n. First of all, I will factorize n square minus 1 equals to 66p, and then n square minus 1, as you know, if I have a square minus b square, it can be factorized, becomes a minus b, a plus b. So n square minus 1 here, I can factorize it, becomes n plus 1, n minus 1, or n minus 1, n plus 1. So I got n minus 1, n plus 1 equals to 66p. So after I transform this equation, I will obtain this one. Same as the expression given in the question. Next, since either n minus 1 or n has to be multiple of blah blah blah, and either n minus 1, n or n plus 1 has to be multiple of blah blah blah, I will stop here. I will find E and F first, and then after that we will continue to read the question. As you can see here, they say n minus 1, n, and n plus 1. n minus 1, n, and n plus 1 is the expression from here. This expression is equals to 66 times p. You have to remember, yeah, p is an integer. So p here is an integer. Since I have 66 here, I can express 66 in its vector. I will express 66 in its product of the prime vector. 66 is equals to, I will write down here, 66 is equals to 6 times 11. 6 is equals to 2 times 3 times 11. This is the product of prime vector for 66. So my equation now becomes n times n minus 1 times n plus 1 is equals to 2 times 3 times 11 times p. Once again, you need to remember that p is an integer. Okay? Now, from this equation or from this expression, you can see that either n minus 1 or n has to be multiple of course n or n minus 1 here has to be multiple of either 2, 3, or 11. 2, 3, or 11. And if you see here, E and F are mutually prime. So E and F here is a prime number. So n minus 1 and n has to be multiple of either 2, 3, or 11. Of course, my answer is not 11. Why? Because E is only one digit number. So here E is either 2 or 3. And also n minus 1, n, and n plus 1 has to be multiple of F. The same concept, n minus 1 or n plus 1 has to be multiple of either 2, 3, or 11. But since F is only one digit number, of course I can eliminate 11. So the answer here is either 2 or 3. Also here is either 2 or 3. Since E less than F, so I can deduce that E is equals to 2 and F is equals to 3. This is my answer for E and F. By the way, if you think about why there is no n plus 1 here, because n plus 1 has to be multiple of 3 instead of 2. Why? Because if n plus 1 is multiple of 2, let's say n plus 1 is a multiple of 2, then n is equals to 1. When n equals to 1, n minus 1 here becomes 0. So, if you see from this expression, when n equals to 1, the left hand side is equals to 0. So, n equals 1 is not our choices. So, n plus 1 cannot be multiple of 2. That's why they only say that either n minus 1 or n has to be multiple of 2. Okay? And then we know that n times n minus 1 times n plus 1 is a multiple of blah blah blah. Since n minus 1 and n, either n minus 1 or n, has to be multiple of 2, and either n minus 1 n or n plus 1 has to be multiple of 3, that means n times n minus 1 times n plus 1 is a multiple of course, 6. Because one of these two expression has to be multiple of 2. And then one of these 3 term has to be multiple of 3. If you times or multiply all of them, that means there will be 2 times 3 times blah blah blah. So the product of all of them must be multiple of 2 times 3, which is 6. So G here is equals to 6. Hence, 1 of n minus 1, n, and n plus 1 must be multiple of hi. What is hi here? Of course, 11. So you can imagine, yeah. Imagine n minus 1 is multiple of 2. And then, let's say n is a multiple of 3. That means n plus 1 must be multiple of 11. So, one of them has to be multiple of 11 so that this expression is satisfied. So hi here is 11. And then, so since n less than or equals to CD, what is CD? CD is 65. So CD here is 65. The numbers of n where n minus 1 is a multiple of hi is 11, yeah? Hi is 11 is blah blah blah. They want us to find how many numbers of n where n minus 1 is multiple of 11, but it has to be less than 65. I repeat it once again. They want us to find how many numbers of n where n minus 1 is a multiple of 11, which is less than 65. To know the number of n, I can write down an equation like this. N minus 1 is a multiple of 11. Multiple of 11 means I can write down k times 11. That means n is equals to 11k plus 1. You can substitute k by using a natural number. When k equals to 1, n equals to 12, and then when k equals to 2, 11 times 2 is 22 plus 1, you got 23. When k equals to 3, 33 plus 1, you got 34, and so on until n less than or equals to 65. until we got the largest number of n, or largest value of n, which is less than or equals to 65. Okay, this is k equals 1, k equals 2, k equals 3, then k equals 4, I got 44. And then k equals 5, I got 56. And then k equals to 6, we got 67. 67 already exceeds 65. So I cannot take 67 as my answer. So the numbers of n where n minus 1 is a multiple of 11 is 1, 2, 3, 4, 5. We have 5 numbers of n. So j here is 5. By using the same concept, where n is multiple of 11, now where n is a multiple of 11, we have blah 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 numbers of n. By using the same method, now n equals to 11 times k, and then by changing k by using a natural number, when k equals to 1, I get 11, and then when k equals to 2, 22, and so on, 33, 44, 55, and 66. Once again, this exceeds our range of n. So, where n is a multiple of 11, the numbers of n is 1, 2, 3, 4, 5. My final answer for k is also 5. And then where n plus 1 is a multiple of 11, we have blah 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 numbers of n. I think you can do it by yourself now. N plus 1 is equals to 11k, n is equals to 11k minus 1. By substituting k using whole number, I got 10, and then 21, 32, 43, 54, 65, and then 76, and of course this exceeds the range of n. So for L here, I have 1, 2, 3, 4, 5, 6. There is 6 numbers of n. Last but not least, thus the number of n's is blah blah blah. So the total possible number of n is 5 plus 5 plus 6. You got 16. And the prime numbers among them are, now you just observe which one is a prime number. As you can see, I have 23, and then I have 11 here, and then I have 43. This is all the prime number amongst the possible value for n. If I write down in ascending order, then my answer is 11 for OP, and then 23 for QR, and then the last one is 43. Okay, that's it for this question. Thank you guys for watching this video till the end. I hope I see you guys on my next video. Bye bye.